How many people are watching? 3 waiting. It looks like it's us two and then someone else. If we don't get much attendees, we can always push the recording.
Yeah. I always default to, if there's not many people attending, like I go to a lot of Q&A, because if they want to be here and they want to ask questions, like, why not? Oh, we're live.
Well, here we are.
All righty. We'll wait till 8 to start.
Yeah, we can give it a moment and then get into it.
I wish I had some awesome lobby music.
Some elevator music at the time.
I guess while we're waiting, if you're here, drop a hello in chat. A GM. Let us know where you're from. Yeah, too, while we're talking, like during the presentation and stuff like that, if there's anything that you want to jump in and add, feel free to interrupt me.
Yeah, for sure. I'll definitely interject with
Yeah,
any kind of relevant insights.
perfect. Amsterdam. Man, funny story about Amsterdam. I had a trip scheduled there for April of 2020. That trip didn't
April
happen.
of 2020. So like right
Yeah.
before the pandemic dropped.
Yeah.
And then they canceled.
Yeah. Have to make it there someday though.
Yeah, it's a beautiful city. Never been, but it's like the city with like the tulips and everything. Is that Amsterdam?
Do what?
It's got like the tulips and like the whole kind of like
Yeah, and the canals and stuff.
the canals. Yeah.
Canals, yeah.
All right. Cool. I guess we can get started.
Cool.
So for those of us who have came, thank you for showing up. We're going to be having a workshop today with Richard from Chainlink. Richard is going to walk us through the Chainlink kind of developer experience. And yeah, I'll be here to just kind of comment and kind of nudge in with any kind of thoughts I have along the way. If you have any thoughts or questions, please drop them in the chat. We'll definitely get to it. And yeah, without further ado, Richard, the floor is yours.
Perfect.
Excited for this.
Yeah, thanks. Let me go ahead and share my screen. So I am Richard from Chainlink Labs. I am a developer advocate there. And yeah, today we're going to talk about what is Chainlink. And if you would like to, you can play along hands-on. This will be kind of a hands-on demo. Just given the time that we have, it might be a little bit fast, so don't feel like you have to keep up if you want, but you could follow along if you like. We'll be doing everything for the most part on the Sepolia testnet, maybe a little bit on Mumbai with Polygon as well. So just if you want to get anything set up, know that ahead of time. So the first question, what is Chainlink? Now, when it comes to that, before we get into that, I want to just make sure everybody's on the same page as far as smart contracts and the purpose of smart contracts and why they are important. Traditionally, agreements always relied on the middleman, and you had to have trust in that middleman, right? And depending on where you are in the world, the legal system and everything could work great, could not work so great, but doesn't always guarantee that those agreements will be met. So that middleman also requires there to be trust. And at Chainlink, we like to say that truth is better than trust. So smart contracts can replace that middleman with a smart contract. So you have a truth-based cryptographic agreement that will take place. And it doesn't just have to be things when you think about contracts as like a legal term. It just means that when something should happen, it's going to happen. So when it comes to smart contracts, they exist on the blockchain, and the blockchain has this thing where it needs to have all of the different nodes within the blockchain reach consensus. They all need to be in agreement. And if you're in the Twitter space, don't give away the answer to this question, but I have a question for everyone. What's 1 + 1? Sunny, can you answer this question? What's 1 + 1?
Pretty sure that's a 2.
Yeah, it's 2, right? And I say the same thing. So that's a deterministic value. That means we will agree no matter when it's asked, where you're asking this question and stuff like that. The other question that we have is, what's the current temperature? Now I'll just check on my Apple Watch here. It's 49 degrees where I'm at. What about you, Sunny? How is it up there in Philly?
Here it's nice 52.
52. It's warmer in Philadelphia than Texas. That's amazing. But yeah, so that's an it depends question, right? Like it depends on where you are. It depends on when you ask this question. That's a non-deterministic value. And that is the problem with blockchains is non-deterministic values. So that leads me to one of these great movie moments, where we have phenomenal cosmic power in the blockchain. Everything is amazing. But we have this itty-bitty living space in that we have to have deterministic values. That's often referred to as the Oracle problem. We need a way to get that real-world non-deterministic data into the blockchain to make it as powerful as it can be. So the answer to the Oracle problem is, funnily enough, called oracles. And that's what Chainlink provides. So Chainlink is a solution of providing oracles to enable you to bring real-world data on chain. Now, you might think, okay, so I need to bring data on chain. How do I do that? Well, you're going to need a node, right? Some piece of software, some server somewhere that will do that. So you have your data sources. That node will then add them to a smart contract. And you can set it up like that, right? You can have a single node and do that. But to me, that's kind of a weird way to do things when it comes to taking a blockchain, which has this decentralized compute infrastructure. It's distributed, it's reliable, redundant, and you insert a single point of failure in there. So Chainlink approaches this by having a distributed Oracle network. So that means that there's a bunch of different oracles that all communicate together. And what do those oracles provide? Well, they provide a few things, and we'll walk through these in the demo. I know I'm going kind of fast. If you have any questions, feel free to drop them in the chat, and I will do my best to get to them. So the first thing that Chainlink offers is data feeds. And data feeds are, as the name implies, a way to get data on chain. Most common is going to be asset pair data. And so you'll bring, whether it's like ETH in terms of USD or something like that on chain, and the different nodes in the Oracle network will all report their prices, and you'll see them on chain. We'll take a look at that here in just a moment. The next is VRF. It's a verifiable randomness function. That's going to be getting your random numbers on chain in a reliable way. Now, there are ways to generate pseudo random numbers on chain using the block hash, for example, or something like that. But that can be problematic when you need actually true random numbers. Think about like this. If we're on the right and we're the user and we have our smart contract here that uses something like the block hash to generate that random number, and we have the node that's going to be mining that block, the node can essentially wait to mine that block until the block hash returns a value that is beneficial to them if they are a bad actor. So with Chainlink VRF, you remove that and you have the Oracle network generating this verifiably random number and bringing that back on chain. Next, we have automation. It's going to be automating your smart contracts. Smart contracts are fantastic, except for they're kind of lazy and that they don't do anything by themselves. So automation enables you to automate your smart contracts so that given a certain condition being met or a certain time frame, you can have those smart contracts run. And again, we'll take a look at all this and get into it a little bit more here in the demo area. I know I'm kind of flying through what all we offer. So again, the automation, you set up the automation and it goes out to that Oracle network, and that Oracle network then reaches out and runs the function within your smart contract. And then finally, we have the newest thing. It's in beta still, but it's Chainlink Functions. To me, not just because it's the newest, but it's the most exciting piece of product that we have currently. It enables you to run JavaScript in your functions in a distributed compute fashion. We'll take a look at that, but this is huge because it enables you to access APIs. It enables you to run complex computations off-chain and bring that data back on-chain. And when it does that, it does it in a method that uses that distributed Oracle network. So I know this is kind of a busy diagram here. But if we start on the left, we have our smart contract that then talks to the functions contract that will send an event to the DON, the distributed Oracle network. And each of the oracles in that network will then use a sandboxed environment and execute that code, whether that's just JavaScript computations or an API request. It'll get back the response, and then it will aggregate that information back to your smart contract on chain. I think that's huge. Like, it basically opens up the entire web to smart contracts. And we'll take a look at that here too in the demo. So yeah, that's it for like products and a super fast overview. I want to walk through all these different products. But before we do that, are there any questions? I don't know, Sunny, if you have questions, anyone in the chat has questions, I'll pause for a moment.
Looks like we're all clear.
All righty. So the first thing we'll take a look at here is our documentation. If you head to docs.chain.link, that's where you can learn about everything. And it really is the best place to start for every piece of information you need with Chainlink. I come here all the time just to make sure I'm doing the right thing and the most current thing. Another thing, I mentioned data feeds. We'll take a look real quick at data.chain.link. This is a good way to illustrate how data feeds work. So we have our different data feeds. You can see they're on different networks. If we just pick one, say ETH/USD, and take a look at this data feed, you can see here we have our trusted answer. That's going to be the result for how much ETH is in terms of USD. On the right-hand side, you can see the different oracles that are reporting their values. And you may notice like some of them have different values, right? We have 1414 and 1412, for example. So that'll show you that despite the fact that this is a non-deterministic answer that's being provided right from the Oracle standpoint of how much ETH is in terms of USD, we then aggregate those together. And given this response set here, you can do a median value on it and get the deterministic value. A lot of times people ask questions like, how does this update? When does it update? So if you look at the trigger parameters, you can see if the price changes outside of this deviation threshold, that will force an update to the price. Also, there's a regular heartbeat that happens that will also change the price. You can see how many oracles are required at a minimum, as well as how many are currently responding and when it was last updated. So this is pretty cool. We can take a look at how to actually use data feeds. So if we head back to our documentation under data feeds, using data feeds, if you scroll down just a little bit, you can see that we have sample contracts in here. And one thing I love about this space is you can just click the button, open Remix, and it'll open that code sample in Remix for you. So there's not even like copy pasting. It's like one button click. It's fantastic. From here, if you're not familiar with Remix, it's a IDE that's based in your browser for doing Solidity development. It makes it really easy to do basic contract deployments and stuff like that, interacting with them. Once we get into like multiple contracts and importing different things, it can be a little bit tedious to do that in Solidity, or sorry, in Remix. But overall, it's a great tool. So from here, walking through this contract really quick, you can see that we have an import of this aggregator v3 interface. The aggregator is going to be what takes all those different responses from the oracles and aggregates them together. So we'll bring that into our contract. We'll call it price feed. This example is set up on Sepolia. This aggregator is for Bitcoin in terms of USD. And you'll notice here there's an address. If we head back to the documentation, one thing to note is that within data feeds, there are different addresses on different networks. And where's that? Missing the link here, but each different network has a different address as far as the price asset pair goes. So if we were to look at the ETH/USD address, it would be different here. So we set that up, we have our constructor, and then we get the latest price feed. And in here, in this code, this is kind of weird in that Solidity requires you to have a placeholder for all of the different values that are returned from a function. So this latest round data returns a bunch of information that we're not actually using in this example. And that's why it's going to be commented out. So it'll return things like the round ID, the price, which you actually want, when this round was started, when it came in, and how many rounds it was answered in. So these commented out values, they're just there to kind of make it understandable. Otherwise, it would literally just be like comma, int price feed, comma, comma. And that's kind of confusing, especially from an example standpoint. So that's a fun little bit of solidity knowledge there. You need those commas to hold the places. So we've got this all here. We can deploy it. If you have done this before, you know that the terrible thing is to never select, or when you don't select your injected provider here, and you're like, hey, nothing's working because I'm deploying it locally. So we need to make sure that we pick our provider, which will pull in MetaMask, and then we can deploy this contract. And so yeah, while we wait for this deploy, any questions?
It's making sense to me.
Cool. This was the best part. What is your go-to while you're waiting for deploy, Sunny?
My go-to for
Do what?
my go-to as in.
Like, do you internally hum Jeopardy music or? So we've got this deployed, and all we have here is this function, right, that gets the latest price. If we run that function, we can see the latest price here is this massive, massive number. Now, I'm curious, anybody know in the chat why it's such a large number for the price of Bitcoin in terms of USD? I don't know how bad the lag is here, but yeah, so precision, Sunny says, it's because Solidity doesn't have the concept of floats or decimals. So this is a decimal number, but it's being represented as an integer. So we'll need to go over by 8 spaces. So 1, 2, 3, 4, 5, 6, 7, and 8. We'll add a decimal in here, and that'll give you your actual value. So that can be found within the price feed information as well, like how many decimal places. Essentially, if it's a fiat currency, it'll be 8. And if it's not, it'll be 16. So here we're being represented in terms of fiat currency USD. So it'll be 8 decimal places. Cool. So that is data feeds in a nutshell, super fast. Any questions from anyone there before we move on?
That looked really easy. That was gonna say.
It is really easy. So like it's super simple to get that data back off chain or on chain into your smart contracts, I guess I should say. So move on to automation, maybe a little bit less easy because there's a couple more steps. So again, going to the documentation, automation, we have 2 different types of automation. So we have time-based automations, which are going to be, as the name implies, based on time. It's going to be based on simply a cron tab entry. And the other type that we have is custom logic automations. If you have heard of Chainlink keepers, they got renamed to automation. So that's just kind of a little bit of, if they've seen anything about keepers, that's what automation used to be. So we'll take a look at time-based automation, walk through that. So the first thing that you're going to do is you're going to need to go to automation.chain.link, and you'll need to register a new upkeep here. So we can do that really quick. And here you can pick whether you want it to be time-based or custom logic. Again, we're going to pick time-based, and we're going to run into our first little roadblock here. We need a contract address to automate. So let's go make a contract. I have this amazingly technical contract here that will count, and it'll keep track of how many times we've counted, right? So we have our public counted variable, And then we have a function to count, which will increment it by 1. So let's go ahead and deploy that. All right, so it's deployed. We can see here counted is 0. If I click count, it'll run a transaction here. And counted goes to 1. Awesome. But I don't want to sit here and click this all day, right? Like I want to automate my contract. And so we can do that with automation. We'll grab our contract address here. We'll head back and we'll paste it in here. And it'll say it can't fetch the ABI. Now, if I had verified this contract on Etherscan, it would be able to fetch that automatically. But since I didn't, I'll need to provide it. If we head back to the compiler tab, at the very bottom, there's a little tiny button that says ABI. We can copy that. And the ABI is essentially a way to let other programs know what your contract can do. It's like an API, and essentially it's the application binary interface, but it's basically just a JSON object that contains the different functions that are available and what kind of inputs and outputs they take. So we give it that, and then it'll let us know, hey, here's all the functions in your contract that we can call. Which one do you want to call? Our contract has one, it's called count. So we'll say, yes, we want to call count. And then we need to give it a cron tab expression. We have a basic thing over here explaining what the different values are. We'll just go ahead and run this every 1 minute. There's another website, I believe it's called crontab.guru, that will break this down into a very human readable format. If you are unfamiliar with crons, you want to make sure it's doing what you expect. But you can see here, we also give you the next 5 times that this will run, so you can make sure that it's going to run the way you expect it to. We'll click next. We'll give it a name, call it counting. We can give it a gas limit. So this is going to be the maximum amount that the automation can use. We'll give it a link balance. So link is going to be the token that enables the Oracle network to run it, and incentivizes them to run what they're paid in. If you don't have any link, you can head to faucets.chain.link here, and you can grab some link and some test ETH if you need it. But we're good there. You can provide your email and a project name if you like. The email will be used to notify you of things like, hey, your link balance is running out, so your automation is going to stop, that kind of thing. But if we register our upkeep here, we need to confirm a few things. So we'll deploy the actual job contract, and then we'll go ahead and request the upkeep registration. While we wait for this, heading back to the documentation. For custom logic, if you wanted to use this, there are basically 2 functions that you're going to need. You'll need to create a compatible contract, which will have a check upkeep function that returns a Boolean. That will be the thing that when that's true, then it will go ahead and form another function called perform upkeep. And so those 2 functions together make a compatible contract. It's also recommended that check upkeep, which returns a Boolean, that same kind of logic is in your perform upkeep function, just to make sure that you actually need to perform upkeep when it gets called, and it doesn't accidentally get called when it's not supposed to. People often ask too, with automation, how do I ensure that people don't call my contract other than the upkeep network or something like that, right? If I only want it called every 5 minutes, how do I ensure that someone else doesn't call it, like every minute? And to me, at least, you kind of need to have a little bit of a mind shift of, hey, I need to set up my contract so that it doesn't matter when the function is called, that function only performs its action when it should. If someone else wants to execute a function for you in your smart contract, if they want to pay your gas bills, let them do that, right? Set it up so that they can do that, and it's not a problem. It looks like I should have given it more link. It's complaining here that we need to fund it with some more link. So let's go ahead and do that now. I'll go ahead and fund this upkeep, and I'll give it another link. That's going to be based on, that minimum is going to be based on the gas limit I set and the maximum amount that it could cost to perform this function. It shouldn't be anywhere near that though, just to increment the counter. So that's done. And if we scroll down, we can see kind of the history of our automation, of our upkeep. So we've funded it. And if we refresh, we can see we funded it again. And hey, look, perform upkeep happened, right? And it tells us how much it cost. If we head back to our contract, take a look at counted now. Hey, we've got 2. So that means the upkeep will be incrementing this on its own. We don't have to do anything else now. It'll automatically every minute just keep counting until it runs out of link. Well, this example is kind of basic, right? We're just counting. The implications here are pretty huge. You could set up things to at a certain time you want to make a mint for an NFT be active. Maybe you have a dynamic NFT that once a day you want it to change based on the weather. These are the type of things that I think are really cool when it comes to automation, because you can do a whole lot with it. So again, I'll pause for a moment. Sunny, anyone in the chat? Any questions, thoughts, comments?
That looks really cool. Also pretty straightforward experience. Yeah. I do have a question regarding testing, but I think at some point that'll become more relevant. So I'll hold off on that.
Okay, sure. I'm curious, Sunny, from your side of things in the Superfluid realm, how do you see automation playing in with Superfluid?
Yeah, great question. So I could picture it being used for the automatic starting, updating, or closure of streams. So let's say I know that someone's going to start working for me in July, that I want to be able to schedule the stream to exactly start in July, such that there's no kind of delay in the compensation that I'll have to deal with paperwork or something, right? I can set the people that will, or an automation that will just trigger that the perfect time, then it makes life easy. So things like that just go hand in hand with payments, I see useful here.
Okay, cool. Yeah, I think that kind of thing, starting, stopping things at specific times, is also a great use case. That way you don't have to make sure you click a button at the right time. Cool. I don't see any questions in the chat, so I'm gonna move on. Heading next into the docs for VRF. So that verifiable randomness function, those random numbers. How do we get that? The first thing you'll need to do is, again, create a subscription. Similar to automation, these subscriptions, I like to think of them as just basically a bucket when it comes to VRF. So you create a subscription that's going to essentially hold your link for you. And then you can authorize other contracts to interact with that subscription. And so you have one place to kind of control all of your VRF stuff if you'd like. So we'll create a subscription. We'll connect our wallet again. And the admin address is going to be my wallet address. We'll create this subscription. We'll wait for it to be confirmed. While we're waiting on that, we can take a look here. This is all explanation of everything that you need to do here in the documentation, but we're going to kind of skip that because I'll talk you through it. We'll open another example contract in Remix here. And within Remix, walk through this contract. We import, again, an interface for VRF, as well as a consumer contract and confirmed owner. There's a few things that we'll be using. We can see here within the contract, we have a few events that we sent a request and we got a request fulfilled. So the way VRF works is when you initiate a request for random values, you kind of send that off to the coordinator, and then those random values will be generated by the DON, that distributed Oracle network, and sent back to you. So those are those two different events. We have a status to look and see, what's the status of our requests. We have a subscription ID. So that's going to be the subscription that we just created. We'll get an ID back from that. So we need to let our contract know about the subscription, and we need to let the subscription know about the contract. We have a key hash here, which is going to be a gas lane for which gas lane we're going to be using. That is important when it comes to the fulfilling that randomness request, because when you fulfill the request, it's going to call a function, and the payload that's calling into that function will be those random values, but you can do things in that function as well. One thing I've done in the past is I've used this randomness to mint an NFT. So that's where the gas lane comes in, because sometimes that fulfill randomness function can be a fairly expensive function. But you can say, hey, I want to get a random number, and when that random number comes back, then I want to do something with it immediately. And that's definitely like how we recommend using random numbers as well, is that when they come back, you use them immediately, because if you don't use them right when they come back, then they become not as random, because a known number isn't random, right? So we have our gas limit for that callback. We have number of confirmations. This is how many block confirmations need to go by before that number is provided back to you on chain. The lower this number is, the faster you'll get that random number back, but the less secure it'll be. So the higher it is, the slower it is, but more secure. We can also get back more than one random value at a time. You'll see here it's called words. This is a interesting little artifact in how VRF is set up, and that the technical computer science term for these values is words, even though they are all digits. But we call it number of words. So in this case, we'll be getting back two different random values. And then we have the VRF coordinator address here. Again, it's going to depend on what network you're on. So you can find those addresses in our documentation. We set up our constructor. We set up the consumer contract with the coordinator passed in. And we set up our interface, we save that subscription ID. And then we have a function to request those random words. So again, this is going to be that function that just reaches out to the coordinator, says, hey, I'd like some random values. We save things like the request ID off. We emit our request sent event. And then we have our fulfill random words value. That's going to be when it comes back in. So request random words, you could call this function whatever you want. You could say, just give me random numbers. That could be the name of the function. But fulfill random words, that's going to need to be that name that all the time, because that's what the contract, that's the coordinator contract, is expecting in your contract when it comes back in. And this is also where you could do that interesting stuff, right? Like whether you wanted to pick a raffle winner or mint an NFT or whatever you wanted to do, this is where you do it in the fulfill random words. We have another function down here just to get the status of the request that we can look at to see where things are. So we should have our subscription. Yeah, we'll need to add funds to it. Add some funds. We'll wait for this to be confirmed. And this will give us our subscription ID that we need to deploy that contract. Okay, now we'll add a consumer. This is kind of a weird space, right? So we've got the subscription created, but we don't have our contract deployed. So we need our contract address here. Our subscription ID is 387. So we'll head back to here and we'll deploy this with the subscription ID supplied of 387. So we're deploying our contract, letting it know about the subscription. Once it's deployed, we'll let our subscription know about our contract. All right, we have our contract here. Head back to our subscription, give it the address, confirm this. And once that's done, we can call things like request random words, and that'll give us back our random values. Okay, so we've got it added. And we can see we have our history here where we've added this, but when we request those random values, we should see that as well. So we'll confirm that. Request should be sent now. So we head back here, give this a refresh. It may take a second. Should show up there in just a second. There it is. So we have a pending transaction now. Maybe it was here and I just missed it a minute ago. But we have our transaction that's been sent to the coordinator. It's gone out to the Don. We're waiting for that response back. You remember, it does take a few blocks to go by for this to happen. So it does take just a tiny bit of time. So we can look here back in our contract for the latest request ID. So it'll give us the request ID. We can look at the status for that request ID. And it looks like, hey, it's been fulfilled. So we've got our request in here, and the two random values we got back are here in this array. We have one here and a second there. So these random numbers, they're fairly large. Common questions that come up around random values is it possible to get the same number twice? The answer to that question is yes, it is possible. It's very unlikely. Like, you can see what these numbers look like. They're fairly large numbers. But given that they are truly random, there is that possibility that yes, you could get the same number twice. You'll need to probably take these numbers and do some sort of manipulation to them to get values that you want that are actually useful within your project, whether it's like using like a modulo on them or something like that. But that'll be up to you. But yeah, so that is VRF. So we've gone and gotten a random value back on chain from the Oracle network. So we've looked at data feeds, we've looked at automation, we've looked at VRF. Any questions on any of that so far? No? Okay. We'll move on to Chainlink functions. This demo might take a little bit longer because we need to talk through a little bit more stuff. It's a little bit more involved, especially considering this is still in a beta phase. If you head to functions.chain.link, you can get access to the beta. If you fill out this type form, we'll get you access to the beta, to the whitelist, so that you can actually use functions. But Chainlink functions, so what they are is a method of bringing the power of off-chain compute into your smart contracts super easily. It is really, I don't know, I'm blown away by these because they enable so much potential in the Web3 space. Like, access to everything that Web2 has basically is now available in Web3. So probably the easiest place to get started with functions is if you head to our GitHub under Smart Contract Kit. We have a functions hard hat starter kit. There's a README here. On our YouTube, I have a walkthrough of this README if you would rather watch and kind of follow along, where we walk through all the different functions setup and how to get going. But we'll kind of do a fast version of that today. So the first thing you'll need to do is you'll need to go here and clone this repo, run npm install. You'll need to get the private key from your wallet and store that in your env, as well as an RPC for the network of choice that you're going to be using. For this demo, I'm going to be using Mumbai, and then a Polygon or Etherscan API key as well. If you want to verify your contract, you don't have to. The example that we uses coin market cap to get some values back, and so you'll need an API key for that. But yeah, so let's dive into the actual repo itself and take a look. So we have a repo here. Like I mentioned, the first thing to do is create your env file. This example will walk you through what you need to add into there and where to get it. Once you've got that set up, we can take a look at the functions request config. So the way that functions work is in this repo is this request config basically contains all of the settings for your function calls. So you can see here we're pulling in our .env file, for example. We have different return types that we can return, but most of what we're going to be looking at today with this file will be in this request config. Specifically, line 34, we have this source. That's going to be the file that we're reading in to actually do our functions call. So this will be the JavaScript file that you're reading in. Now, the JavaScript that you're going to be using needs to be a plain vanilla JavaScript file, no imports, nothing like that. So currently it needs to be just plain JavaScript. Can make it a little bit more interesting to create those JavaScript files without having the ability to just import everything you need, but it still is really powerful and really capable. You can see too that we have a secrets value. This is going to be that API key. So the secrets are encrypted and passed to the Oracle nodes where they can be used. We have our wallet private key. We use that when we're doing things like deploying contracts. We have arguments that are passed into our functions. So we can see what these are used for here in a moment. These are all going to be different values that are passed into API calls. And then finally, we have the expected return type. So in this case, the return values that we're expecting are going to be uints. So we look here and we see that our source file is this calculation example.js. If we take a look at that, it's over here. We can see that this is a fairly complex computation to determine continuously compounding interest. If you were going to do this on chain, it would be very gas intense. It would cost a lot of gas to run this computation on chain. So this is one example where Chainlink Functions comes in and saves you a ton of gas because you can take this code, execute it off chain, and return that value back on chain. And I mentioned that distributed Oracle network. So this code will be run by each of the oracles in its own sandbox environment, and then their values will be aggregated back on chain in a very similar fashion to how data feeds work, right? Where we have each oracle reporting its answer, and then the value being returned back on chain of the median of those answers. So once this code runs, it's then going to be passed into the contract function consumer. This is that contract. Not spend too much time walking through this contract, but essentially it sets up a bunch of values for our functions call, like the latest request ID, response, and error. We have our event with that response. We have our execute request. This is going to be what actually initiates that request for functions to be called. And then we have our fulfill request where we'll get that value back. And we can see here that we'll emit that response. So we'll take a look at this on chain here in just a moment. But how do we actually give this a go? So the first thing we have is npx hard hat functions simulate. So what this is going to do is it's going to run our functions call locally. So it's going to simulate the actual call, but it will interact with this contract locally as well. So if there's something wrong with this contract, you'll see it here. And we can see that our functions call, heading back here to our code, what do we have here? We have this total amount and we return it as a uint. So we can see our code here that the output gets encoded as a hex string, but that value really turns out to be this amount, right? So what is that? 1,000,000 and change. So this is that value that would be then returned to our smart contract. And we can see here it simulates that. It gives us a gas usage estimate for everything. But if we wanted to actually deploy this, we can take a look at the README, and it walks through, and we'll look at it on the website because it's a little nicer. So we ran functions simulate, right? The next thing we need to do is we need to actually deploy it. So we'll use this npx hard hat functions deploy client. That will deploy our client contract to our network of choice. You can see here we need the network name and if we want to be verified or not. So we can add that in here. And so I'm going to deploy it to Mumbai and verify it. So it'll take just a moment. And I don't know, while we're waiting for all this deploys and everything like that, Sunny, if you have any questions or thoughts, comments.
Yeah, I'm liking the kind of simulation environment that's able to be created here. Like this isn't us deploying to a testnet, right? We're working with a local environment, or am I getting that wrong?
So no, you're right. This last one that we did, so this deploy client, we're actually deploying it to Mumbai, but the function simulate that runs locally. And what's great is before you actually make, you'll see this in a moment, but before we actually make a functions call, once we've got everything deployed, it runs that simulation again and asks you, hey, are you sure you want to do this? So we've got our contract deployed here. If we wanted to go take a look at it. Oh, I thought I would have a link here, but we could go take a look at it on Mumbai testnet. Let's go take a look real quick at that. We can see that our contract is actually deployed. Cool, so it's deployed and it's verified. We've got our nice little green check mark. We can see what it does. So we'll come back here and look at the transactions in just a moment. But we've got our contract deployed, right? So this is our consumer contract. We need to, in a similar fashion to what we did with VRF or automation, we need to create a new subscription. So we've got this NPX hard hat functions subscription create. We'll need the network name. We'll need the amount of link. We'll need our contract address. So we'll pass in all those values. And again, this contract address that we're passing in, it'll need to be the one that we just created. So we'll create that subscription. Again, a few things like that you're not seeing here is that we need to have in our wallet some link for the network that we're deploying to, as well as some of the native token. All right, so it's creating our subscription. It's adding that consumer. This is kind of very similar to how things worked with VRF, right? We created a subscription. We added the consumer contract to it. And so you can see here that we created a subscription. Here's the ID. We'll need this ID in just a moment. We have the balance. We have one authorized consumer contract, and it gives us that. Cool. So now we need to actually make that on-chain request, right? So we'll run this command. We have our functions request. We tell it the network, and then we can pass in a gas limit, but we need to give it the correct subscription ID, which is 334. And we need to give it the proper contract address. So we'll give it that. And with this will allow us to actually run first the simulation, right? So we can see here our simulation. If all of the callback gas is used, it'll cost this much. So it gives us that estimate, basically the upper limit of how much this will cost. It gives us our sandbox code locally output, right? What that value is, and asks us if we want to continue. If we select yes here, then we're actually making that call to the blockchain. So we're actually doing something on chain at that point. So we'll say yes. And we'll hang out for a second while it confirms everything. All right, so we got our response back. If we head back to Polygon scan and take a look real quick, we should see here, we have this event and we have this response. Which one was it? It's this F50ED. I don't read hex very well. But if we change this to a number, we can see here that on chain, we've gotten our response back and we've gotten that number back as well. So this is that calculated continuously compounding interest value that we did off chain and brought it back on chain. So I think that's pretty cool. I think that's pretty awesome that you can do these complex computations now for a much, much lower gas fee. The other thing, if we look back in our config file, you may have noticed that there's a line right below our source file that was commented out. We have this API request example. If we take a look at that code, this one starts to use things like those args that we have in our config file as well. So here we have one Bitcoin, BTC, Bitcoin, BTC, and so on. We get those and we save them here. So one of those is going to be the Bitcoin ID on CoinMarketCap. Another is going to be what it is on CoinGecko, Paprika. And then we have this bad API coin ID, just to show kind of what happens when you have an API call that doesn't work. We check and make sure that we have that API key for CoinMarketCap. And then we go ahead and make all of those different requests, right? So we go out to the URL and we get the values back for each of those APIs. We store all of their responses. And then if there's an error, we log that out so we can see that there was an error. And after that, we go ahead and grab the median price of the different responses. And that's what we're going to be passing back on chain. This is pretty cool. So we're making 4 different API calls, and each of the different Oracle nodes will be making these API calls independently and coming up with its own answer to what the median price is, and then returning that back. So then the median of those prices gets reported on chain. So what's nice is we've got our consumer contract deployed, right? And since this is a fairly similar thing, our consumer contract will still be doing the same thing. It's just going to be emitting that OCR response. So we don't need to redeploy that. We don't need to create a new subscription. We changed in our request config the source file. So now all we need to do is the exact same command we did before of, hey, we want to make a functions request. And you'll see here things look a little bit different, right? So we're running this simulation. And so we get this console log message, hey, the bad API failed. That's not good. We could fix that, right? We could go into our example here and we could fix bad API by getting rid of it, but we'll leave it in there for now. And then we got our median Bitcoin price returned. And we can see what it would actually be when it's passed into the smart contract. So, hey, do we want to continue? So yes, let's go ahead and continue. So even with that error in there, we still got a valid response back, right? Because we're calculating the median of the good responses that we got back. So we can still use this as a valid use case to bring that information on chain. Because we're using multiple APIs, we have that redundancy built in. So cool, we've got our request and our response was returned. And here's that value that was returned back on chain. If we head back to Polygon scan, give this a refresh. We should see here, hey, we've got a new one. If we do this as a number, there we go. We have our new value being back on chain. So yeah, I don't know. I think that's pretty cool. I've been working on an example of integrating Chainlink functions with ChatGPT to do like AI and Web3 blended together, which is pretty cool. I'll have a video coming out on that in the not too distant future. But yeah, Sunny, that's all I got. I've got time for questions, thoughts.
Yeah, that was awesome. Seeing your demo of the Chainlink functions. Yeah, I think also you kind of teased that idea of the ChatGPT use case here. Would love to see that tutorial when it comes out. And
yeah, so that'll be coming out probably in like the next week or two on the Chain Dev YouTube channel. It's kind of our side channel for Chainlink for developer focused content.
That's awesome. Maybe just like a couple of questions on my end. I just would like to learn a bit more about like testing with Chainlink. So let's say I'm doing the data feeds locally. I'm pulling like say Bitcoin data, and
Sure.
I want to test a different scenario where say Bitcoin price has moved to, you know, a lower level or a higher level. And obviously I could do like a mainnet fork, but the mainnet fork would freeze the conditions of the chain, and I would get like the initial price, but not the you know, I wouldn't be able to, I guess, like forward around and kind of change the price as I'd like to. Is there some kind of like a, you know, kit where I can, I guess, do that kind of submitting of information on my own? What does that kind of experience look like?
Yeah, sure. So within back in our GitHub repo, smart contract kit, the hard hat starter kit. So not to be confused with the when we were just looking at the functions hard hat starter kit, although it probably has some of the same stuff in there. The hard hat starter kit has tests in it that do allow you to do like the mocks and stuff like that. So you can mock up responses from data feeds, VRF, automation. It's pretty cool. I don't know that we want to go too much into like the how to. The README is pretty good there, explaining how to get all of that running. But that would do what you're talking about, where you're running it locally via hardhat, and you can use those mocks to get the like, you know, mocked responses back from all of those different things.
Okay, that's great. There was one time I was trying to use like this other Oracle for some sort of lending contract I was making, and
Hmm.
the process of doing that was just such a headache that I literally had to like stop using it. So good to see that it's out there for Chainlink.
Yeah, we have quite a few different starter kits. I know that the hard hat one definitely has the mocks built in really well. The other ones will to some degree, but definitely hard hat's probably the one that we've spent the most time on recently.
Awesome. Yeah, I love hard hat. They're my go-to as well.
Yeah, here it is. If you want to see
Yeah,
that, like
maybe
so we have,
Foundry is next up for you guys.
yeah. So we have starter kits for Brownie, hard hat, Foundry, a TypeScript flavor of hard hat,
Mhm.
and a few others. So
Sweet. Out of curiosity, do you work on those, or do you guys have like an engineering team that works on those?
it is a combination of us and so like the dev advocate team, as well as some engineers and stuff like that.
Got it. Cool. Another question would be, so what is the kind of difference in developer experience look like between deploying and, creating things on test nets versus on mainnet? So is there like a kind of distinguishment, or is it still the same sort of like basically the same thing?
Yeah, the experience, like from the developer standpoint, would be the same. There's no real difference there, with the caveat that like functions, right, still in beta, just on test nets right now.
Mhm.
But yeah, as
Got
far
it.
as like experience and what's there, like if you go to any of our products, like automation, for example, it's the difference is you just are clicking this drop down and go into the proper chain.
Cool. Okay, that makes sense. Have you been seeing any like interesting community like contributions or products in the community already coming up that are using Chainlink functions?
So we just announced it at ETH Denver. So there was some
Okay,
interesting hackathon use cases there. But yeah, it's super fresh.
gotcha. Cool. Not sure if I have any questions off the top of my head right now. I think this was a great walkthrough in each case. If our audience wanted to perhaps get back and see some of the code you wrote and access some of the documentation, would you be able to provide those sorts of links?
Yeah, so all the code and everything that we went through today is all in the documentation. So like docs.chain.link, with the exception of the functions starter kit where that code's there. I mean, with the exception, I guess there's this one thing that wasn't in the documentation, but I think that's not too complex. But the rest of it, like seriously, the documentation, like I'm not trying to show my own company's docs too much here, but like the docs team at Chainlink is phenomenal. They put a ton of effort into our documentation, and like the ease of use I found it's just, I don't know, I love it because all the code we went through today is straight from the documentation. Click button, open and remix, and away you go. So for sure.
Yeah, I love how you guys use Remix. I think Remix has this ability to like freeze at different like gists. So I think that's what you guys kind of use, right? To
Yeah.
like default code into it. Yeah,
Right.
cool.
Yeah. We have these like code sample workspaces that have all the different samples in them.
Yeah. Looks like we don't have any questions in the chat. Looks like Irvin thinks I'm right. I'm asking all the right questions anyway. So appreciate that, Irvin.
Doing a
Cool.
good job. That was good.
Sweet. Well, Richard, thank you so much for this workshop. Really got us through all the core components of developing with Chainlink. Looking forward to seeing what people are going to build in the wave pool with Superfluid and Chainlink. I think there's a ton of design space, ton of things to build from what we talked about in the last Twitter spaces. So yeah, Richard and I will be on hand in the Superfluid Discord to help with any kind of questions, any ideas that you guys are hacking on, any developer support. I'll be in the Chainlink server as well, in case you guys are over there with questions. And yeah, feel free to reach out. putting more comments in there. We'll get around to it. And thank you so much for your time, Richard.